So continuing on with these vector projection problems, there are going to be times where the angle between the two vectors are obtuse. So what's going to happen is the parallel vector, if you remember the definition of parallel vectors can have an angle between them of 0 or 180 degrees. So when you go to try and find W sub 1, which is your parallel vector, it may be forming a 180 degree angle with vector V as opposed to a 0 degree angle. So for example, let's take a look at example 2a. We have vector U, which is 4, negative 3. So there's U, and there's vector V of 2, 6. So what happens is when I go to find the vector W sub 1 and the perpendicular vector, it turns out to be on the outside right here. So here's my W sub 1, here's my W sub 2. Excuse me, W sub 2 is the perpendicular one right there. Okay? Still the same formula to calculate the components of W sub 1 and W sub 2. So I know W sub 1 is going to be the dot product of U and V divided by the magnitude of vector V squared times the components of vector V. So the dot product of U and V is going to be 4 times 2, which is 8, plus negative 3 times 6, which is negative 18, which gives me a negative 10. Magnitude of vector V squared will be 2 squared, which is 4, plus 6 squared, which is 36, and then I square it. So that's going to give me just 40. So then W sub 1 will be equal to negative 10 over 40 times the components of vector V, which is 2 and 6. So I end up with negative 1/4 times 2, 6, which is negative 2/4, which is negative 1/2, and negative 1/4 times 6 is going to be negative 6 over 4, which is negative 3/2. So there's W sub 1. W sub 2 can be found by taking vector U and subtracting from that vector W sub 1. So vector U is 4, negative 3, minus W sub 1, which is negative 1/2 and negative 3/2. So 4 minus negative 1/2 is 4.5. Negative 3 minus a negative 1.5, so negative 3 plus 1.5 is going to give me negative 1.5. So there's my W2, W sub 2.